Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I'm going to talk today, shortly, dinner's following, about smart clients. I guess originally in the old days we had thin clients. That's where everything was centralized on a server, and you got a piece of the action by just leaning on that and running what it is that you needed to do. And we stepped into the fat client world, where you had heavy-duty applications sitting on your desktop. And now we've entered the smart client realm, where you have heavy-duty applications sitting on your desktop, but now you have the advantage of the internet to be leveraging information that's somewhere else, so that way you can always stay fresh with what's available. So we have an application we're going to show you called WorldWind, which is based on smart client architecture. It's built with the .NET framework. And just a small bit of history on the .NET framework aspect. We actually started down the C++ OpenGL route, and we found some difficulties in porting that between multiple platforms. For purposes of speed and reliability, stability on the Windows platform, which was our primary market, we switched over to C# and DirectX. And what we found, brass tack, firsthand, is that it took about 1/10 to 1/100th of the coding effort to accomplish the same task. So we were instantly charmed by this particular programming environment. So if you want speed of development and you are on the Windows platform, the .NET, Microsoft has really done their homework in generating the libraries needed to work in that environment. I also want to express a great amount of gratitude to the Microsoft Bay Area Research Group, Jim Gray and Tom Barkley, because they have offered an inordinate amount of support that actually was probably extremely influential in actually allowing this project to actually exist. So with their support in terms of helping us deliver the data off of TerraServer, and it's in the terabytes, and their guidance in terms of how we were delivering that data, we've really accelerated, I feel, in terms of our ability to deliver this data effectively. And one last comment is this nice workshop, eScience workshop book. If you want a sense of the vision for WorldWind, if you go to page 21, you'll see that's Jim Gray's page. But there you'll see WorldWind mentioned in 3 of those headings. And if you want an idea of where you can go with WorldWind, there's a major suggestion. So I would call that our vision statement right there. So with that, we've got 10 slides. Randy says that's 9 too many, so I'll try and move through this very quickly. Randy Kim is our lead designer. He's responsible for the interface on WorldWind. We'll get to the actual application of WorldWind very quickly. So next slide. What is it? Richly interactive 3D planetary visualization tool. But I might add, for those of you who work in things besides the planet, maybe you work with the brain or you work with the heart, you can use this surface to represent any body you want, and you can, in a sense, contextually attach the kind of information to that body for your particular device. So think of WorldWind as a portal, a contextual delivery portal to your kind of information. Smart client architecture, et cetera. Why NASA WorldWind? Well, because NASA has a lot of planetary data, so that's what we're delivering for the most part. And next slide. Algorithms optimize integration, seamless blending of multiple data sources. This is interesting. When you're working with WorldWind and you're accessing data, as you zoom in, that data is coming from multiple servers in multiple formats. WorldWind doesn't care. It takes that information from whether it's PNG or JPEG or GeoTIFF, it could be on different servers, and it translates that into a format that is now on your system. So once you've accessed that data is now yours locally. So the next time you go to access that data, you're not pulling it off the server. It's now localized. So if you wanted to actually go someplace offline, you could download the data, and then you have it. So it's doing this dynamically, blending this. Let's say in this case, it's blending elevation data with image, Landsat imagery data, and if you want to throw on topo maps on top of that, it's bringing all that. So you can have these multiple layers of data controlling the transparency of those layers. One interesting application would be you could also have a layer that's just flat, and you could show the rising of sea level or the lowering of sea level and see what land is submerged or actually rises. And Jim has been pressing us to get something because he's very interested in the bathymetry of the oceans. And our next version, which will be out at the end of this month, which is version 1.3.3, will do negative elevation, and we expect to have at least Death Valley represented in there. But we hope to get our hands on the bathymetry data for the planet and then make that navigable in 3D as well. Okay, next slide. API architecture. So we want to be leveraged. We want you to use us. We want you to take advantage of us, press us to the hilt. So the idea being that WorldWind is a visualization tool to deliver information, but it could be whatever you want to do. Currently, there are hundreds of plug-in applications generated by the open source community that now leverage WorldWind to deliver their particular information. Classic example right now is Katrina. The NOAA and the U.S. Army Corps have done a lot of flyovers, made all that imagery available. Someone in the open source community actually mosaicked all that imagery, and now the National Guard, who is the responders for Katrina, is using that data inside of WorldWind to see the before and the after, the areas of concern, and that kind of business. So the idea is that anyone can add any data that they want, including just pointing at their servers to deliver their data. You can change the entire menu system, which you'll see in a minute, the menu system. But if you don't like that menu system, you want buttons that you use. You want buttons that when someone clicks on that does something different, you can set up your own entire menu system via an XML file. So you're not having to change the core code. You're just having to change the XML file, and now WorldWind will do something entirely different for you. Next slide. The air traffic patterns for the planes we fly in actually changes every 28 days. This is a 3D, you're not seeing it right now, but this is a 3D representation where you can actually see the different elevations of these particular flight lines. Next slide. This is a bunch of data that gets leveraged, all, again, simultaneously, depending on how many layers you want to make live at a particular moment. Next slide. The kind of data that NASA delivers, this is the kind of information that we're serving up inside of NASA right now. Next data via WorldWind. We're talking with the UN about a variety of things, including early warning system for tsunamis, for tracking locust activities in Africa, so the intervention can be, I guess, optimized. And if you can imagine an early warning system for tsunamis, everybody can own a copy of WorldWind, and it's sitting at the coffee shops along every coast. If the servers that have the information that are collecting for earthquake information or for the wave information by the buoys that are out in the ocean, and that information goes to a server, if you're running WorldWind on your particular PC, no matter where you are, you can be immediately notified that something's going on. So talk about getting information out to the people who need to know quickly. You've got it. So that's one example. The U.S. Agency for International Development is doing some data, NASA supporting the development of some, I guess, natural resource management for 10 Central American countries, and so it's being used for that particular project. Next slide. Next slide. Okay, 100,000 new unique IPs per week. I guess there's about 1 million downloads of WorldWind in every month that's going on right now. And we're just running a prototype server for special data sets. And even on our little prototype server, we're getting over 100 requests per second for imagery. Now, Microsoft Terra Server is getting a heck of a lot more requests per second for imagery. So the interest level in terms of implementation for NASA WorldWind is relatively high. Next slide. Okay, I think this is the key. Open source benefits. If you're a researcher and you build a functionality, that functionality is now available to every other researcher. They can either extend it or just add their own additional functionalities, and now everyone's benefiting. So there's a very beautiful evolutionary aspect to this approach to science, in the ability for all the researchers to share in every other researcher's efforts. So it's really not only not having to recreate the wheel, it's actually being able to expand the wheel. And next slide. Provides a standards-based platform for effective expansion of information delivery and infrastructure. I think that's kind of obvious. Open standards, open source, digest any format. Shape files, Esri shape files, we digest those. So if you have that data already from ArcView, you're able to run that inside of our particular program. And let's see, unlimited commercial opportunities. Yeah, that's the other thing that's kind of interesting. If you want to build a proprietary application and you want to leverage WorldWind with that, that's a beautiful aspect too, because as WorldWind evolves, you built a plugin that's actually leveraging WorldWind. As WorldWind evolves, your particular plugin that you have sold, that you are making money off of, you have a very broad market of customers, so you don't have to charge very much to make a profit. And as WorldWind increases in functionality, your plugin is going to be able to leverage those new opportunities, whether you change the plugin or whether the plugins take advantage of those functionalities as they come along. And I guess last but not least, the NGA, which is the National Geospatial Intelligence Agency, the people take care of all the mapping for DoD. They've submitted WorldWind to NSA, which is now a security agency. So it looks like it's going to become a standard part of the Department of Defense implementation for looking at the world. Next slide, which aren't any. Okay, so now before, we're going to go through WorldWind, but before I want to show you a little movie. On this next release that we're coming out with, which is a very, I guess, there's a great amount of improvement in terms of this, the usability with this next release, version 1.3.3. But one of the things is we're including the moon data, and it has never been seen before, and that's something internal to NASA. So if you want to run that moon movie, can we do that? Okay, this is a movie that just, it's a lunar demo, but and we're taking you through, but as a user, you would be able to fully navigate your, this at will. This is something that has never been seen before. NASA's been holding on to Clementine moon data for the past 10 years. The only way you could access it was via a website, and you scanned across these postage stamp tiles of information and said, oh, I like that. I'd like more raw data about that. Now this is the first time all of that data has been assembled into a 3D visualization tool, which is just a portal to the information. So now what will happen is researchers are going to be able to look at the moon as the moon, and then wherever they go, they're going to actually be tied into a query system that looks up and tells them what raw data is available, and they'll be able to order that raw data specific to an area that they're now visually experiencing, which makes it a lot easier to go about your research exercise. Okay, so with that, let's just go into playing with NASA. I guess Tycho coming up. Well, okay. So now we'll just play with WorldWind for a couple minutes, and if you have any questions or challenges as we move about playing with it, please feel free to ask. I'm just going to try and show you some of the basic functionalities of WorldWind. So across the top is, you can see a bunch of menu systems, menu items. One of the things is there's 5 million names. So here's a place that you can search for. Does anybody know some one-horse town that you don't believe could be found inside of WorldWind? B-E-R-E. A-L-S-T-O-N. Where's the two words? R-E. So B is one word? That's it? Okay. Don't tell me we've been stumped. Okay, bingo. Okay. So, thanks for not embarrassing me. You tried, though. I'm sorry? Something more difficult? Wait, well, trust me, we got 5 million names there, and it's just going to grow. And I'll bet if we found it, it's probably going to be in the wrong place anyway. We're working on making the place names sitting dynamically on a server so all the corrections can be made, because there's people in countries that are saying, hey, this is 2 kilometers off from where it really is. We're just getting the names from a national atlas. It's, and it's 5 million. It's kind of hard to groom, so we're going to try and set it up like a wiki and let people edit it at will, and hopefully we'll get a better quality on those data. So, yes. Washingtons? Oh, yeah. So put in the word Washington, and you'll get a lot of them. Right. And what's fun about this is that anyone you click on, you will actually rotate to that part of the world so that you can actually see, well, is that the one I want? And it moves around. So then you can pick, okay, till you finally find it. Yes? The query of the seafloor? The seafloor, yes. We don't have the names in there for the seafloor. But as soon as Jim and I actually get this bathymetry in, just like that moon you saw, we actually got those place names for the moon somewhere that were sitting on the web already. So I'm going to imagine that all the seamounts and trenches and things like that will be available.
So can I look at drift, let's say, at a place 2 million years ago?
Right. So, yes, in terms of the plate tectonics, there's 2 ways to go about this. There's full-blown animations in terms of already generated video that wraps around the Earth and shows all of that. The other part is, let's go to the web server. So if you have a WMS server and you have a bunch of data, for example, maximum temperature on a daily basis is collected and made available. So you put that each day's, or it could be each minute, whatever you wanted, on your web server, and then the person, in this case, once we see those servers, it's having a hard time recognizing what's out there. But once you do, you'll see the whole hierarchy tree of what's available on that server. You take the starting date and the ending date that you want, and then like a DVD player, you control an animation, and hopefully this will pop up. Saturated? The wireless network is saturated.
Everyone here is downloading copies of
Well, don't do that yet. Wait for this next release, please. Don't just wait for this 133, because there's some really dramatic changes that'll make it far more exciting. So, if for no other reason, but the principle, I guess we're having a hard time getting it. But the principle is that yes, you can do it 2 ways. 1, with the WMS server, you can control the animations yourself, and then 2, you can actually generate full-blown movies that are in the cylindrical format that just wrap around the Earth and show that. One of them is Scientific Visualization Studio out of Goddard. One of them is the Globe server. You may have heard of that. That was mostly for education, but there's been a lot of other, I guess, NOAA data has been put on there. And those are the 2 that we have implemented in here right now. But we're working right now to bring in PODAC. I guess NASA has a lot of servers called DACs, Digital Active Archive Centers. And those are being rigged to be WMS. Thank you. What did I say? Yeah, digital, distributed, thank you. Yes. So, but it doesn't have to be one that we've already rigged. If you have a WMS server that you want to point at, you just put that into the XML file so that's now there available. When you click on it, you're looking at that particular server, and you don't have to do anything else. And then the data, no matter what it's in, PNG, TIFF, JPEG, will be available, translated into DDS, which is optimized for the video card inside of on the Windows platform, and then you can view that information. Was there another one that I missed? Exactly. Oh, in terms of what's available, yeah, if you go to the Globe server, you got maximum temperature, minimum for the past 10 years on a daily basis. So barometric pressure, ozone, earthquakes. Oh, we got an RSS feed for earthquakes, so if you've got this thing turned on, you're going to get the earthquakes as they come off from USGS immediately. So, and we're also building one for fun with the Reuters news agency that will take the heading title and extract from that the city, and then we go to our database, find out where that is lat long. We put an icon on the earth where that is, and when you click on that particular icon based on colorizing it to subject and putting it in location, then you actually point at the Reuters article. Just an example. Okay, this is the earthquake information. So when we click, do we click on one of those? What happens? That's it. So you get the magnitude and the date. The amount of, we have a new data set coming up that will be, what you're seeing, the best we have for the Earth right now is 30 meters. Well, it'll be 15 meters, which is so darn good that it's almost 10 meters. But at the very least, for the United States, we go down to 1 meter for the entire United States, and thanks to Terra Server, and we go down to a 1/4 meter for some major metropolitan areas, thanks to Terra Server. And actually, all this data that you're seeing is also delivered by Terra Server. So, and what's fun is you can play with the vertical exaggeration. If you don't like the natural one, which is 1, on your number pad, you can hit whatever number you want, and it'll change the vertical exaggeration to be, look like something from Fantasyland. It's right. So it's actively, when it gets that right, it finds up the mesh and does a better job of representing realities. There's a lot of interest from other countries to actually get their data made available at a much higher resolution as well, for a variety of things, whether it's for tourism or for its emergency response to major disasters. So, and that way, everyone who's working to solve the problem will have access to the best available information. So, you want to show the boundaries, and then we can show the flags? That's kind of a fun one. So, you can turn on the boundaries. You get to see all the boundaries. Let's go over to Europe. That's much more interesting. And it's working on bringing all that in. It brings all that in. There should be, and if we bring it, because I'll tell you, we've got more complaints from people over in the Slavic countries and Israel because the boundary is just a hair off someplace, and they just are raising holy hell with us. So they're saying we're trying to control, the direction of where the boundary is actually supposed to be. So now we bring on the flags, and so we turn on the flags of the world, and what happens is that puts the flags in each of the countries. There's a more dynamic. Okay, now when we click on any one of those flags, this is where we do, if the browser's not already running, oh it is, now we go to the CIA World Factbook that gives you all of the information that you could possibly ever dream of about that country, which is absolutely amazing. And what we hope to do is actually get the past 10 or 15 years of CIA World Factbook data, so the trend of those countries in terms of whether the birth rate's going down or going up to kind of get a sense of where the sensitive areas are that might need attention, or the ones that are doing well, and to understand why things are working well there. So here's a great geography tool as well, obviously. Anything else that we might want to oh, landmarks are fun. Turn the flags off and go to landmarks. So the wonders of the world, if you ever wanted to know where they were, and of course all of us say, geez, yeah, that's kind of interesting. So they will turn a lot of the major landmarks on, yeah, including the Kremlin, and Michelangelo's David and Leaning Tower of Pisa, but some of the Egypt's pyramids of Giza. And so you can click on that, and what that does is it takes you to Wikipedia, and you get to see a picture of it, an explanation of it, and so that's how that kind of thing. So it's the dynamic nature of this is that all you have to do is make an XML file. This is not coding you have to go inside the program to do. Randy is not a computer science major, and he's the one that built all this XML file to actually account for putting these dynamic things, making these dynamic things available. So it's not just, that looks like a McDonald's arch, but I guess that's St. Louis. Anything else in terms of, well, let's go to the Grand Canyon for fun, Grand Canyon, go to Yosemite, just to give a sense of some of the higher resolution stuff. Yosemite? So here you're seeing 30 meter. We're going to have 15 meter, almost 10, at the end of this fiscal year, or excuse me, this calendar year. And what you're seeing is the 30. It's going to get a whole lot better than this. And now we turn on the 1 meter stuff. And now you get the Ansel Adams-esque view in 3D. And now we're down to 1 times the vertical exaggeration. So there's half dome here. That's what it really looks like. And if we turn on the Topo Map to throw on top of that, here's the Topo Map. Now, this next version of 1.3.3 will allow you to control the transparency of the Topo Map, so you'll actually see the imagery beneath while also seeing the roads and the layout of the. And if we zoom in better, we'll get finer and finer resolution on that particular Topo Map, or this Topo Map. So I can promise you, it does get much more sweet than that in terms of resolution. And then the next time we would go there, it would pop up immediately because it would have been cached on your local drive. Yeah. We're pulling them from no other place but Terra Server. Those guys. They're servicing everybody. You can blame Tom Barkley and Jim Gray for the fact that it's working so well. So, and believe me, these things, their server's getting hit pretty hard, and it's still delivering every image at about 200 milliseconds. So it's extremely phenomenal performance. Yes?
I have a question which is not that much related to your data.
Oh, well, then we don't want to hear it. Sure, would you please?
No, it's just a question of curiosity.
Yeah.
Recently I've come across a video pointing to something called Metacarta. Have you heard of that?
Yeah, refresh my memory, though.
Metacarta. Apparently the government has bought into it. It's a service where they sort of, like you said before about the newspaper articles and showing the hurricanes or things like that.
Right.
And they're sort of doing that type of thing. They're just searching for keywords and mapping them onto the globe or something like that. I'm just wondering if you have seen any of that or are you aware of that?
All I know is that, yeah.
I want you to know about that.
Right.
I don't know anything about it. I'm more asking you whether you know about
No, I'm not. I'm not. What NASA's decided to do just this past week is to actually build a query engine to use WorldWind for all of our planetary data and then accessing the archives in terms of all that information that's available for a particular planet at a particular location. So some of the algorithms that have been discussed here in terms of intelligent accessing of information, if you would like to work with us on that, I'm sure we'd be very interested in collaborating in terms of that kind of effort. Yeah. But there's no reason why someone couldn't build a plugin that actually, took advantage of that, that lookup table for that kind of information and related it in a particular context to where it might be on a 3D body.
There was an article in the San Francisco Chronicle about Google campus on Comet 2.
Yes.
And there was a link to the NASA data. And are they going to be using WorldWind? It's a great tool.
That's a ticklish subject. So you couldn't ask me a more difficult question. No, but I don't mind answering. I mean, because WorldWind's approaching the same kind of concept in terms of information delivery as Google is, but we're approaching it from the scientific realm, not from the ATMs and pizza parlor realm. So if you want to find a route to grandma's house, from the pizza parlor, that's the better tool to use. If you want to get more information on, scientific data, whether it's satellite information or that kind of thing, then this is the tool to use. But one thing that we are different from, very basically, is the open source aspect. So what happens in terms of ongoing development of this tool, I think, could have the potential to really, if the world community actually does rally around this effort, which we have found they already are, then we're going to have a game. We're going to have a good game here. Jim?
One of the things I've found is that it's very hard to compare data sets from different groups, and that for the astronomers, the only thing they can agree on is the celestial sphere. The way to take two data sets and put them together is to lay them together on the sphere. I think a similar thing is going to be true for environmental science. The only thing you can agree on is time and space. Beyond it, there's much bigger.
And the other part, too, is that with Google, when you download information with Google, that's proprietary information. That's copyright protected. All the data that we're leveraging is public domain. You can do anything you want with this information. You can turn it into a cartoon if you wanted to. So there's a whole lot of freedom associated with this, not to mention a whole lot of flexibility and adaptability in leveraging it the way you might want to do. And then I think the evolutionary potential for it to actually service more and more of the world's informational needs is potentially there, much more so than something that actually has an API that the rules can change and the cost structure can change. So where would you go in terms of delivery of information? So I guess is this where we are right now?
No, we're the one right below it. We're the black, where it hasn't been built. It's only a year old.
Okay, well, let's go back 10 years. And if we bring the Topo Map on top of that, we'll see that what this actually was the golf course. So in terms of data sets, I think they're just going to get richer and richer. I think there's going to be a lot of ability to do the kind of analysis with playing with the bands and how you mix them up to extract some of the things that are going on with the vegetation or other aspects of Earth processes. It's going to be a wonderful tool to address the global climate change issues. And actually, we just got moved over to the exploration group next to the supercomputing group, which will be able to deliver some of their information. Yes? The what?
The domain of an atom.
The
structure of the brain.
Yes.
One of the problems that we have in this field is that there is variability between individual brains. So the shape and structure of the brains change from one example to another. With humans, in quite a dramatic way.
Yes.
Quite a lot of difference. How do you envisage dealing with those kind of statistics? If this was a tool that was used to map data into the human brain,
Right.
how would one deal with
This shape, this nice geoid shape, can be a potato. It doesn't have to be a ball. So, right, yes. We are very much interested in going to that interior mode in terms of depth with regard to our 3D visualization. Right now, we're dealing with a surface And all the action is really on the surface, even though we're showing layers that might be in a different elevation. But in terms of penetrating the Earth, I mean, the most logical thing we want to do first was actually show you could go into the Earth and show the pressure change, the temperature change, till you got to the core. Once we get to that stage, then there's going to be a lot of meta-tagging of information based on your location. And of course, there's going to be a need to actually represent that the way we saw the heart as a 3D body, fully 3D. So that's our next step. And I see that actually coming about next year in terms of that kind of functionality.
What's going on here largely is this is the benefit of the game software.
Bingo. Yeah.
That's what's really driving this. You try to do this with a supercomputer, it's really slow. And they use smoke, and they use clouds. And so they can do planes. And so we've done, with the oceanography, we've done ocean currents this way. And the people in San Diego Supercomputer Center are struggling to do something comparable with, what the ATI and NVIDIA parts. They're very expensive. They're $500-600. Try some price here in DC. It's an awfully good deal if you want to. But it doesn't give you a ubiquity. That is to say, the reason he's having to use his laptop rather than our laptop is because he's got a better graphics card than the standard laptop. And I can get the demo on this guy, but it's not as nice as
And
Say how big of an effort they're looking at your huge heat.
oh yeah. It was the CTO of Google Earth, Keyhole actually, came over and talked with us and said, we tried to figure out where we could work out together about a year ago, how we could join forces. We didn't really find the formula. But at that meeting, he said, we got to tip our hats off to you guys because it took us 30 engineers and 3 years to do what you did with one engineer in 1 year. You're looking at a coding effort of one individual who was fresh out with a computer science bachelor's degree who had never touched a line of C# code in his life. And he built this. It's this guy's best friend. And so this nice friendly interface design is a result of him, and the other is a result of the genius of a guy named Chris Maxwell. Now, I must add to that a gentleman named Tom Gaskins, who is a giant in the computer graphics field, actually wrote the first basic application that didn't have 3D terrain, but it did have a 3D Earth, and you just were always perpendicular to it. What Chris Maxwell added as a result, that's when it was C# and OpenGL. But as a result of moving over to the DirectX drivers, we were able to free up the camera to 6 degrees of freedom and add the elevation to turn in terrain, so you had a reason for moving the camera around to see it that was more fun. That was all a result of one fresh out guy who had never touched a line, and he actually did this in a matter of months in terms of translating that kernel into what you see today. And since then, we've just been adding increased functionalities. And I might add that someone, very industrious someone, and I don't know why Microsoft hasn't given them some kind of award, but some guy took this code and actually used 6 days and explained what he did on each of the 6 days to change this code to something that would run on a Windows CE platform. In other words, your little handheld. So WorldWind runs on a CE. And it took 6 days, and on the 7th day, he went to Hooters. So it was just a phenomenal effort. So you're going to see this on cell phones. You're going to see this on little CEs. You're going to see this in a lot of places, I think. So well, no, you don't need that. Seriously, you won't need that because the way he had it run, it was running just fine on Windows CE. So in terms of effortlessness in terms of the code development, we just can't say enough about the .NET platform. And Microsoft has done their homework in putting those libraries together that we're just leveraging the bejesus out of, that we would have had to write the libraries for if we were using anything else. Yeah.
So recently, Google has taken a lot of flack about the satellite imagery that they have, and some of it being kind of up to date and sensitive to particular defense
Yeah, the Senate had some kind of thing out there where they said they wanted to make all this kind of, this kind of imagery, verboten, that just they can't have it. And I think that it kind of died. I don't think it's alive and well right now. For one, it's going to screw those satellite companies' business model, and I think they stepped in the way. But in terms of a world hungry to see itself and to know itself better, to understand the processes of a planet, to understand how round this place is and how beautiful and fascinating it is, I mean, I think that's a crime to even consider deprivation from access to that kind of information. But yes, that has been bandied about, but I think it's been, for the moment, neutralized. Will it, creep back up? I don't know. It might.
And the interesting part, too, is if you go to D.C. and you look at the Capitol, this is all USGS stuff,
Yeah.
The Capitol is actually all pixelated out.
Yeah. The White House, all they do, they pix off the roof. So it's, it's like, what are you hiding on the roof? I mean, who cares? So it's kind of ridiculous. And the other part is that this is not live delivery of information. This is really, this is, like a year old for the best stuff. And the grayscale stuff is 10 years old. And the Landsat imagery is maybe 3 or 4, 5 years old. So this is not really compelling information in terms of security issues at all, in fact. And by the way, you can get better maps from AAA than you can from this place. So there's, I guess, a gentleman named Steve Lombardi. Is it Steve Lombardi that's the program manager for Virtual Earth? Yeah, he's just told us that we're allowed for any non-commercial use to access all of the data that is being delivered by Virtual Earth. So anything that you can see in Virtual Earth, as soon as somebody figures out how to access that database, that server that's holding the information, we're allowed to deliver it in WorldWind on a non-commercial basis. So that's going to be fun when we see that information made available, because they got some really good data there. Yes. Well, it's going to be fun. There's a lot of business models that are coming up around this thing that are proprietary in nature and have to do with international companies and their supply chain and seeing where their products are coming from, trucking companies to see where their trucking is, analysis of their trucking routes to see how much fuel will be consumed. I mean, there's a lot of models that are coming out to leverage this information. So in our mind, it's encouraging entrepreneurial enterprise in a very significant way. So we're trying to make it fun for as many people as possible. Thanks to good hearts of NASA, and thanks for, seriously, this project probably would not have gotten to this stage if it hadn't been for Jim Gray and Tom Barkley stepping in and providing the amount of support in terms of delivering the data. We had the data on our servers, and we brought NASA's network to its knees, and they kicked us out of the building. They said, you can't do this. There's too many people accessing the imagery. And too many people downloading the program. The program right now was 188 megabytes, so it was still being downloaded 1 million times a month. We got it down to 45 megabytes. That 45 megabytes, 40 megabytes of that 45 is the 5 million place names. So as soon as we offload those 5 million place names, you're going to be downloading less than a 5 megabyte application. And as soon as Windows Vista come out, you're not going to have to install the .NET libraries or the DirectX libraries. It's just going to be all integrated on the platform. So that's going to make things really, really sweet. I think I'm running over here. So as Will Rogers would say, never pass up a good opportunity to shut up. So.